Okay, this might be my favorite one. There's Dory. It's me. Just keep swimming. Just keep swimming. Just keep swimming. Just keep factoring. Just keep factoring. Okay, we have a special type of factoring for you today. It is brought to you by the number 2 because it happens when you have two terms. So, if you have two terms, there's two things that it has to be. It has to be a difference, which means there has to be a minus sign, and they have to be perfect squares. X squared, x to the fourth, those are perfect squares. 1, 4, 9, 16, 25, 36, 49, etc. Okay? If it is a difference of squares, it just factors into, it's a bada bing, bada boomer. So you make two little parentheses. The first one is the square root of a squared, which is a, plus the square root of b squared, which is b, times a minus b. So these are the exact same terms. One's a plus, one's a minus. Okay? The two rules are must be a minus sign. Okay? We can't have a sum. Must have a minus in between. All right, I'm trying to just be patient while you're writing it down. Dun, 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 dun. And the other one is both terms must be perfect squares. Okay, that's what we talked about at the top, but write it down. Now, it will behoove, I love that word, it'll behoove you to learn your perfect squares up to 100. So I'm going to look at this one. The first thing I notice is there are just two terms. Is that what a real Dory looks like? Because that's not as cute as the fake Dory. But that's cute. It's blue and green. It's very cute. Look, a little puffy. Poof. Okay, they're tired from swimming. Okay, pay attention to what you're doing here, Evans. All right, this is a perfect square. It is m times m. That's a perfect square, right? 64 is a perfect square, 8 times 8. This is a minus sign, so we can go right to our two parentheses, one with a plus, one with a minus. What did we square to get m squared? We squared m, so that's our first term of each one. What did we square to get 64? We squared 8, so that's our second term of each one. Bada bing, bada boom. Love it. All right. Oh, she's much prettier. Look how bright blue that is. Okay, look how she's got the ocean going down here. Oh, Mrs. Colonis is so tricky. Is this a perfect square? Yes. Is this a perfect square? Yes. Is this a minus? Yes. You have to check those three things, okay? So you know it's going to factor into something plus, something minus. What you have to figure out is what did you square to get 16y squared? What is the square root of 16? What number times itself gives you 16? And that is 4. And what number squared gives you y squared? And that is y. So 4y is your first term in each one because 4y times 4y is 16y squared. Got to do the same thing with the square root of 81z squared. What did you square to get 81? That's 9. What did you square to get z squared? Z. So we've got 9z, 9z. Because if you multiply those together, you get negative 81z squared. Here's why this works and why it has to be a minus. If you are foiling, that's that, right? We also have to do this one. So we would have 16y squared minus 36yz. Right here is plus 36yz, and then that's minus 81z squared. And see how those two terms cancel out? That's why it only works if one's a plus and one's a minus, okay? All right, on this one, two terms, so I'm going to go over here. Oh, wait a minute. Wait a minute. Look at her. She's like, oh, defeated. Defeated. It doesn't work. Are those perfect squares? No. Therefore, I cannot do the problem. No! I can do the problem. Do you remember what the very first thing we always have to do? We have to look for a GCF. Do we have one? Yes. What comes out of both of those? A 3. So if you divide them both by 3, you have b squared minus 9. Now, up until this point, we would have stopped there, but now we know that this is a perfect square, this is a perfect square, this is a minus. So keep the 3, set up your difference of squares, that's what it's called. Over here in your head, the square root of b squared is b. What did you multiply to get b squared? And the square root of 9 is 3. What did you multiply to get 9? Do not lose that 3. Okay? There's your bada bing, your bada boom, but don't forget your greatest common factor that you took out. All right, so once again, this one looks like we could go right to a perfect square root, doesn't it? Is 2500 a perfect square root? It is. I'll just tell you, yes, it is. What is it the perfect square root of, you ask? Well, let's find out. You know what? That's a big number, isn't it? What's the first thing I just told you to do? I told you to look for a GCF. Does 4 go into 2500? Now, you're probably going to be doing that on your calculator instead of doing it my mind just went blank. What did I just do wrong? I brought down too many zeros. Oh my gosh, guys, this is why we use calculators. Because look at what I just did. I totally messed up. 625. Wow, that was a mess. So if we take out that 4, what do we have left over? We have y to the 4th minus 625. Okay. Now, y to the 4th is a perfect square. Y to the something squared has to equal y to the 4th. Remember what we do with creepers? We multiply. So this is the square of y squared. So keep that 4. Do not lose that 4. Set up your plus and your minus. What did we square to get y to the 4th? We squared y squared. What did we square to get 625? Well, it's 25. It's one of those that you need to memorize. 25 squared is 625. Oh my gosh, you guys. Oh my gosh. Do you remember when I said double, triple, check, check, double, triple, check, check, double, double, triple, triple, double, triple, check, check? Look at this. See that square? That's a clue that you need to look again. So here's a square and a square. So does this one factor more? No, because of the plus. But this one, that's a perfect square, that's a perfect square, and that's a minus. So we're going to leave the 4, we're going to leave the y squared plus 25, and we're going to factor this difference of squares again. What is the square root of y squared? Y. What is the square root of 25? 5. Okay, now your teacher's going to tell you how to find the square root of 625. There's a lot of different ways, but the easiest one is to use your calculator. Okay, c squared plus 1. Oh, look at that beautiful yellow tail. I'm sure some people know what these things are called. I don't. I call it a fish. I shall call this one Fiona the fish. There's our secret word. I named the fish Fiona. All right. So this one I'm going to set up plus, plus, minus, minus. What did I square to get c squared c? What did I square to get 1? 1, 1. I am happy. And here's what's going to happen when I turn that in. Wrong. What did I forget to check? This is a perfect square. Yes. 1 is a perfect square. Yes. But is that a minus? No. This is prime. This cannot be factored. You cannot factor it if it's a plus in between. All right, that's a 9-minute video. Oh, there's still more slides. Whoops, never mind. Ooh, see? Ooh, there's more slides. How many terms? 1, 2, 3, 4. So it's not a difference of squares, is it? Is there a greatest common factor? Well, they're all even, so I know I can take out a 2. Oh gosh, let's take out that 2. Do you think I can take out anything bigger? I think I can take out a 6. So if I take out a 6, I'm dividing all of these by 6. So I have x cubed plus 5x squared minus 4x minus 20. 4 terms, still going to do the grouping, leave the 6, leave the bracket. What comes out of these two? X squared. So I'm going to divide by x squared. I get x plus 5. What comes out of these two? Remember, it has to be a negative. It's going to be negative 4 Negative 4 divided by negative 4 is 1 with an x plus 5. So here's my 6. What do I have in common out of these two? X plus 5. Take that out. What do I have left over? X squared minus 4. Oh, this is why this is on this slide. Because double, triple, check, check. Remember that square is one of those things that you got to remember to look. Is x squared a perfect square? Yes. Is 4 a perfect square? Yes. Is it a minus? Yes. That means I can leave the 6. I can leave the x plus 5. And I'm going to change this into a difference of squares. I'm going to factor it as a difference of squares. Square root of x squared is x. Square root of 4 is 2. That huge thing is your solution. Wow, this was a double killer, wasn't it? Had a GCF right off the bat you had to look for, then it had a difference of squares at the end. Wow. Wow, that's what that fish is going like, ooh. Checkpoint. Oh my gosh, I love that fish. Checkpoint, checkpoint, checkpoint. Okay, now remember, this n to the 4th, n to what squared gives you n to the 4th? You would be multiplying, so that's n to the squared. So the square root of n to the 4th is n squared. Hint, hint. It's all you guys. It's all you.